In today's video, we are going to talk about buck converters. What are they, how do they work, and a simple circuit that shows how a buck converter works in real life. So, what's a buck converter? A buck converter is the most power efficient voltage regulator. So, how does a buck converter work? There's a capacitor, an inductor, and a diode, and a switch. So, when the inductor over here capacitor over here charges when the switch is closed and also powers the load simultaneously. Since it's an inductor, it opposes the change of current initially and also reduces the voltage drop across it later. Since it reduces the voltage drop after a few time, we will again open the switch and redo everything like this, and when it reaches its peak, we will again turn it off and switch it back. This switching is done very fast in real life that it will lower the voltage. Suppose here that's 12 and we are switching it so fast that here it gets 5 volts, and this capacitor smoothens the ripples when the switching occurs. This diode is used to discharge the inductor like this when the switch is open. So this is the simplest buck converter circuit out here. Alright, since you know how a buck converter works, this is the buck converter circuit which I showed you earlier. Instead of a switch, we are using an NPN transistor for the switching purposes because we require a very high signals. The transistor which I am using over here is an NPN transistor whose part number is 2N42. This circuit over here which you see is a timer circuit with HTML mode. This circuit generates a high and low signal which is also known as PWM or clock signal, which it generates is in kilohertz because of the resistor value and the capacitor value which I have choose here. And the frequency can be changed with this 10 kilo ohms potentiometer which I have connected right here between pin number 7 and 6. And the output is connected to third pin through this NPN transistor's base over here. This base acts as a switch for the main 12 volt supply and controls this output over here. When we increase or decrease the resistance over here, the switching frequency also reduces or increases in this transistor, which in turn reduces or increases the amount of current or voltage flowing through this inductor. So let me build this practically in a breadboard and show it to you according to the same circuit. So this is the circuit I have built according to the same schematic or the explanation circuit which I showed earlier. This is the output of the buck converter. This is the parallelly connected capacitor through it, and this is the inductor which does the actual job. And also note that the inductor which I am using here is very less current. The commercial buck converters use very much high quality ones with a MOSFET instead of a transistor. I am just showing it for educational purpose. This is nowhere efficient as how a commercial one is. So this is the 10K potentiometer over here which I'm using to vary the frequency, and this right here is the timer IC which generates clock signals or square waves. So let me show the voltage across the load over here in the multimeter. So when I increase this, as you can see, the brightness of the LED decreases, which means the voltage at the output is getting lesser. And when I increase it, the voltage of this also increases, thus the brightness of the LED also increases. Also you can see this on the multimeter. The minimum voltage which my circuit can go is 5 volts. Also note that the power supply over here is 12 volt for the whole circuit, and here the minimum output voltage of the buck converter is 5 volts and the maximum it can go is about 9 volts. So I think you got a better understanding of buck converters and how they work. This is the simple circuit. In commercial applications, they do not use a timer IC or something like this. Instead, they use a buck converter IC such as this thing which I am showing here. I might make a buck converter which is very efficient, about 95% in the future video on a pref board. So for today, this is it. I hope to like the video and also give the feedback in comments. Thanks. Bye.